Okay, first, hello everyone. Those of you here and those of you online watching. I'd like to first thank you all for coming to this talk or either watching the talk wherever you're from, and to thank Side Effects for inviting me to be a part of the event. This talk is going to focus on how we, Neon Doctrine, use Houdini in production and development to elevate our teams and to provide value for our partners. In this talk, I'm going to explore with some examples about how we're using Houdini in our everyday production and development processes. We'll take a look at how we use it to help empower our internal teams and how we use it to provide value for our external partners and clients that we're working with. I'll start out very quickly with introductions and then move into why we use Houdini, followed up by how we use Houdini. I'll share with you some live examples of some games we've used Houdini with, and towards the end, just share a little bit about my thoughts of the impact and value that at least we feel Houdini brought to our projects and our partners. And hopefully if there's some time at the end, I'd like to leave the floor open for some Q&A. Lastly, I'd like to mention that this talk is not going to go into too much technical details. However, I will share some screenshots and some movies of node graphs and examples. But if there's any kind of technical questions that you'd like to know some answers to, feel free to email me directly or to connect to me on the socials. I'm happy to follow up or arrange someone from my team to answer any questions that you might have about this talk or in general. So let's start out with me. I'll be quick. My name is Solomon Temowo, and I have almost about 2 decades worth of experience in the video games industry. I founded 2 companies during that time. I'm currently with Neon Doctrine, and Neon Doctrine is my second company that I founded. The first one was Playarium, which I founded in 2015. And Playarium was primarily a boutique development studio that was focusing on technical asset creation and game development. At Playarium, we worked on titles such as Monster Hunter World, Resident Evil Village, Death Stranding, Astral Chain, and more. With Neon Doctrine, as it's my new venture that I've started with 3 other like-minded heroes, my main responsibility is to lead our internal development teams as well as external development partners to make sure that our development processes and the impact of what we develop is engaging for our players and sustainable for ourselves. So I've been credited on over 30+ games, including titles like Horizon Zero Dawn, Tomb Raider, The Last of Us, and many more. And for Neon Doctrine, we are actually a publisher and developer, and our main goal, our vision, is to bring diverse experiences from developers from all around the world to our players. We do this by partnering and empowering new and existing creatives through assisting them on the development side or giving them funding or helping them with PR. We assist each title about their needs accordingly, and we also work with bigger studios and clients to support them as an external developer. And sometimes they're asking us to do porting or full development, and other times it's to assist them on production. So it kind of looks something like this. On one side, we have PR and marketing, publishing on the other side, and development and production services, which is where I am and my teams and responsibilities comes to play. And that's where we use the Houdini magic, no pun intended. And our team, we've got a wide range of experience. They come from many backgrounds, animation. Some of them have been credited on games, like I mentioned, Astral Chain, Village, The Company Man, which is also showing here at Gamescom Asia, Legend of Tian Ding, which we're responsible for doing the ports for all the other platforms. That's also coming to Game Pass, shameless plug. And so the team has a wide range of experiences of working on AAA blockbusters as well as smaller contained game experiences. And another shameless plug, we are hiring, especially people who know how to use Houdini or procedural workflows. Okay, so enough with the intros. And I want to jump into the main body of the talk and start off with why we use Houdini. So we use Houdini to help us to create production tools. This is great because sometimes there might be a specific problem or a repetitive task that our production teams, artists, animators, level designers are facing with our project. And so we can create something that's a very robust solution that can integrate directly into the game engine or other DCC applications. We also use it to improve our efficiency and scope of world building. So it allows us to, with more leaner teams, still build up very large worlds, rich worlds. We do take an upfront hit on the planning and building up the logic of those worlds, but it does pay off in the long term because we're able to build much more richer, deeper worlds that are very receptive to iteration and changes in the everyday situation of the project. We also use it for asset creation and variation, which is great because we can create one asset, expose a couple of parameters, and that could become a completely different asset, which then leads us into being able to automate certain aspects of technical requirements. So automating things like collision generation, UV, texturing, it does allow us to really remove some of the tedious tasks in production and for our teams. And then sometimes our clients will come to us and they have a specific problem on their project, and they've kind of got a specific idea in mind that they want us to help them with, to either build a tool set or a process, or even some other solutions that Houdini seems to be best placed to tackle. And last but not least, it's great to be able to propagate change across multiple assets or across the project. Maybe there's a high-level art or creative direction iteration that needs to be applied to a certain group of assets. And if we set up our project right and we've got our tools kind of set up correctly, it's possible just to make that change on the server side or the database side and then have that propagate to the assets. So it's kind of great for that depending on how you've set it up and if you've set it up correctly. It's a byproduct of having a unified and logical rule set in place for our assets. Okay, so that was the why, and now we're going to go into how we use Houdini, and we're going to go a little bit more detail here. So let's start with the first one. We used Houdini on a game called Trinity Sword 7. The game itself is you could say it's kind of like the Final Fantasy of Taiwan. It's a rich and beloved IP in Taiwan. And up until 2017, the franchise had never been developed for more powerful systems. That time, PlayStation 4 was just coming out. So the client, after seeing the work that we'd been doing with AAA developers, and we were still Plarium at that time, they asked us to contribute to the creative and technical direction on the next installment of the game. And their team wanted us to drive or demonstrate what a next-gen version and workflow and process of this game could look like. So the client was handling the audio, the story, the narrative, while we were handling everything else from performance direction, game design, engineering, lighting. But specifically for this project, we used Houdini, and we used it for mainly parametric assembly of environment elements, as well as simulating physics and effects. We did also use it to create art production tools as well. So I'm going to show you a bit more of that. So hopefully this movie is playing okay for you all. Okay, great. So one of the ways that, at least at Neon Doctrine, that we love to use Houdini is to parametrically assemble assets or components. So basically, we're taking the individual asset or the biome itself and breaking it down into Lego block-like pieces, and then using Houdini or HDAs to drive the logic of how they are put together. This allows us to create really convenient sliders or checkboxes that allow for level designers or artists or different people in the production team to generate variations of these assets. It also allows us to fine-tune and control and keep the consistency of the style and automate other areas of the world building process. This example here that you're seeing is something that we made for the project for Trinity Sword 7. We made it so that it could be very easy for us to create variations of buildings and place them in the environment. The cool thing is that they're really not made up of that many components, and I'll show you what those component pieces look like in the next slide. But it really allowed us to generate a wide variety of assets and variations of buildings that could be used in the game. So when using Houdini in this manner, we do like, when I say in this manner, I mean when using it to parametrically assemble assets and parts together, before we do anything, we normally like to plan it out on paper by defining the rules and the logic of how the parts connect together with the game's specific architectural style. We do work closely with our visual designers and our design team and the concept artists to try to stay as true as possible to the vision, to the concept, whilst also trying to ensure that the technical aspect of the modularity works well together. So we'll do this on paper first before we even go into Maya or any 3D application. And then when we're kind of ready to test out or prove some of our assumptions, we then would create very rudimentary geometry, like you're seeing here. Inside Maya, we would put in some placeholder textures, some quick UVs, just to feel out things to make sure it's kind of going in the direction that we would like it to, before then putting it inside Houdini to start to parametrically build the HDA. The reason why we like to use this way of working with pre-made modular parts and then using them as an input inside the HDA is that it allows for studios or teams who may not be able to use Houdini to create, who may not be able to create the parts directly inside Houdini. It allows them to use kind of traditional ways of asset creation and to start to append these parts to a library. So for some artists who are not familiar with Houdini to make 3D assets or 3D modeling, it can be like overwhelming for them. And so this is quite a nice way to easily start to make parts that fulfill the prescribed set of rules and logic for the biomes and the architectural elements in those biomes. It also allows the option to mass produce the parts that adhere to our rules safely and safely integrate them to the project and to append them to the existing options that production members are using to lay out the scene. So here's a look at what the final HDA looks like when you use it directly inside Unreal Engine. What you'll see here is that when it's first placed in the scene, you're actually seeing the placeholder geometry. We provided some visualization options for our production team members so that if they wanted to quickly assemble a level together without their machine being slowed down by loading the textures or higher fidelity assets, they could then choose that option. Otherwise, it would slow down the machine. Plus, when you start to kind of get it all into a larger open world, things really start to choke up a bit. So having these kind of visualization options really helped in terms of just speeding up the comfort and ease of using the HDA directly inside Unreal Engine. Also, having these visualization options meant that we could very quickly create and block out placeholder geometry and append it to the database. Level designers and other departments could very quickly use them and start to propagate their levels. And then at the same time, an order can go out to our production team members who go out to start making the more finished and final parts, and then append them to our database. So, and then later in development, someone could go in and refresh the HDA or pull in the kind of finalized parts from our production. This allowed us to very quickly ensure that level design or other parts of development or the production team could hit the ground running. They could use the HDAs very quickly with the knowledge that anything that would get final art later wouldn't necessarily move or mess up what they had already lined up. It also gave other team members on the team a bit more context to see how other dependencies or departments were actually using the asset in the game and how it would look when they're actually using the HDAs. So it was a great way to kind of unify all the departments consistently and not step on each other's toes. When using parametric assembly like this, we also like to use control them with data tables. Basically, these CSV files are created inside the engine, in this case, Unreal Engine, as blueprint data tables. The CSV file is controlling the number of available structures, categories, different amounts of parts, different informations that we use to control what is allowed to be used by the different departments. The CSV file is loaded directly inside the engine, and the HDA reads that file and allows the user to apply customization, various options that we've exposed in the HDA already. It's super useful and very powerful. We personally love using this because it allows us to really structure, control, and make sure there is some consistency in assets that are available to a production team. They know that if it's not in the HDA, if it's not in that list, they shouldn't go around to kind of make something else. They kind of stay within that ecosystem. So when working this way, it does require a bit more planning. But when it comes to making iteration on the environment, it becomes much more easier to iterate in a less painful way. And this is due to because we are centralizing and using a unified system to facilitate controlled changes. Another thing that we also did for the project was the production tools. And we had something that I like to call the Rockifier. And basically, it essentially takes any form of geometry as an input, and then it spits out a rockified version of it. And this input could actually be anything from an FBX or an OBJ, or in our case, what we did was directly input Unreal Engine geometry automatically, and then it would automatically apply the rock details, it would make a high poly, it would make the cracks, the pores, and anything that was specified in the HDA. We also exposed some parameters and options, so people could customize it however they felt fit. It would also auto-generate all of the asset data outputs. So, for example, it would auto-generate textures. In this case, we were actually using Substance Designer. It would auto-generate the high poly. It would generate the bakes. And it would also generate things like normal maps, occlusion, collision, shadow maps, as much as possible. And it would do that in maybe about 3 to 5 minutes per asset. But that's a lot quicker than making a request to take a speed model, to make the high poly, to sculpt it, to review it, put it in the game. It essentially allowed us to go from 0 to 70% in less than an hour. So here's an example of how that would look like. This example is just showing a rudimentary speed model that's used as an input. And then the HDA just quickly starts to slap on some rock details. I'm not sure if you will see it. You should see in the top right-hand corner, there's a node which is the Unreal Engine input. So we'll switch to that. So actually, it's possible for like a level designer to block in geometry, get the level how they want it, hit a button, and then it gets this rock-like version ready for the game with all the data, all the game-ready data that's needed. So depending on how the team feels about the result, maybe it's a distant asset and they don't really care about it and they think, okay, it's fine, or maybe it's more of a hero piece. They could either take that and polish it up, pass it over to production to polish it up some more. But because it's already quite close to the 70%, it won't change the bounding box area. It won't change, it won't cause too much issue when it gets sent back to design. So it's a very good and quick way to get a very early approximation of what the final asset might look like. So again, it's the same HDA, just using a different speed model as an input. And we should zoom in on this because you'll see a bit more of the high poly detail that it generates. It's also showing you some of the nodes that we have in place for the low poly and the high poly. So one of the things our production teams really love is the power to automate certain tedious outputs of assets. So things like collision, UV, shadow maps, shadow meshes, even automating the texture application. If you've got a good material ID set up, it can really help on that side too. These are great because the team can focus on just the asset itself, like the high poly, and make sure that looks good. So what we do here is Depending on certain assets, if it's kind of like simple organic stuff like rocks, and it doesn't have like a transparency and it's not too complex, we do like to create the HDA as something like this that can be integrated directly inside Maya or the game engine, and then just drag and drop that HDA into the scene. Now, of course, for certain proprietary projects that have a very specific way of working or have very specific outputs, it might not be ideal in terms of what is required. But for a lot of projects, if there's a bit more of a wiggle room with this kind of exact kind of technical output of this particular feature, it can be more than enough for what you need. So yeah, it's pretty powerful. Of course, there are things like Nanite in Unreal Engine, and Nanite has obviously certain things, has changed the way we do certain things in development. But if your project cannot support static Nanite meshes, this is definitely an alternative option that I strongly encourage and we do like. So the next example project, it's using a similar workflow, but again, this is applied to a mobile title. This is something that we created at Playroom, and it's pretty much very close to the process that I just showed you earlier. But in this one, we started to expand it a little bit more, where it is not just, we're trying to build out whole levels where the outputs are specifically going to run on a mobile game. So the idea was that our team needed to be able to use level creation tools inside Unity and immediately test and output it as game-ready assets on mobile devices. So the project is unreleased. We got pretty far with it and we're really happy with the results. This is the first time that we're showing it outside of our studio. So this movie is gonna kind of show you, like, just on a singular asset how it works, but we really try to make a very simple and straightforward, powerful way to create a building. It would create a building with the exteriors. It also would create the interiors, including stairs. It would create the collision, light maps, everything. And you can see, I don't know if it's big enough, if you can see it, there's just a very long button that says make building. And let me go into the next. I'll let this play a little bit so you can just see how quickly it is to generate these different buildings. And there's a couple of sliders that we move around. We could also save these out as presets. So if someone liked a specific building, they could store that later. Yeah, so, okay. So one of the main missions on this particular tool was to make it so that it was really super easy to generate a wide range of buildings. So in our Houdini asset, we basically just had that button that I just mentioned that would basically make building. It's called make building button. And what I did, every time you hit that button, it would randomize the arrangements of these parts for the building. And it would do that for the interior and exterior as well. And it would be very easy for the level designer to very quickly hit a button and press play. We had to make sure that inside Unity, the technical setup would allow the team to be able to use Unity's built-in features to generate light maps so that they could very quickly go from building out the level or the building to testing it like in-game. So you can see here as you go inside, it's already started to like figure out where the shadow should be. You could actually, there was collision, unfortunately I don't have the movie, but you could run up the stairs and jump out windows and all sorts of shenanigans. One of the other key requirements and goal of what we achieved with this tool was to make it so that we could very easily take one type of building's architectural style and then replace it with a completely other type of building style. there should be a, I don't know if you can see it here. Yeah, so in the, let me see if I can move my cursor. In the HDA, just here, this drop-down menu, you can see it says type. So the idea of, move my cursor back. Okay, the idea of that building type was so that our team could very quickly change the style of the architecture to a completely different style. So imagine that you've just built out a whole city and you're like, oh, damn it, I don't want this to look like New York. I want it to look like a city in Europe. So we could then change it to more European style buildings without having to redo the whole layout, without having to redo everything. We also allowed them to be able to mix and match parts if they wanted to. Of course, it's not ideal. You don't really want to mix and match something that's breaking your project's artistic vision and creative direction. The idea was to really allow and facilitate rapid iteration and change, and empower people with directability. They could really direct the vision. This required a lot of pen and paper planning and structuring. So this video is a little bit long, so I'll try and skip through a few parts, but let me just summarize it like this. What you're seeing is the final set of HDAs that we created for this mobile title. And it would allow level designers to quickly build out and customize the level. It's a very powerful set of Houdini tools that we put together that allow the assets to be generated and run on mobile. And that was the key thing, that whatever they built or edited in the Unity editor, it needed to run on mobile at the push of a button. So you could quickly build out a space and then quickly test it in-game, knowing that it's going to be a close approximation of what the final art and design would look like. So let me see if I can skip forward a little bit so you can see what's happening here. This is all like in real time, so it's one of our production team members just kind of building out the space and then hitting, the randomize button and making some options. But you can see, for us at least, when we were using it in production, it allowed us to very, very quickly build out whole scenes and whole levels, and then test them in the game as well. Let me jump forward a little bit as well. The whole video is about 8 or so minutes long, but you'll see that within that time, that person manages to build out a whole section of a open world map. So you got this here. Okay. Now I'm going to move on to another production tool example. In this example, we were using it as part of an external development situation. We mainly used Houdini to create specific production tools for this particular client because they had a specific pain point that they were suffering through during production. So we proposed a few solutions along with a roadmap and a few other kind of production-related documents for them to review, and then ended up creating a few different tools for them. One of the pain points that we had to solve was they were making a platformer game, and their level designers needed to be able to position their platforms in strategic locations, get their jumps just perfect, and then once it was in place, hand it over to art to then add these kind of grassy trims around it. But the problem was that maybe they went through testing and then found that they needed to make a change, and then art would then have to go back and redo that, redo their UVs, redo their textures, and just redo everything. So we created this HDA that would automatically apply a grassy top. And actually, it's not just a grassy top. It would apply predefined meshes. So it could, in this case, we had grassy top. We also had like a sci-fi-like geometry that you could swap out as well. And it meant that if level design changed the shape or changed the style or of anything, no one really had to redo anything because it would automatically conform to whatever changes were being made. Another similar one, again, similar to the grassy top, but this time it was more about railings. So there might be specific areas that level design wanted to control where the player had access to. Maybe they didn't want the player to jump over a wall. And again, it was the same thing again. They were, creating very specific platforms of very specific shapes and distances, but they needed to be able to iterate that and change that. So let me skip forward here a little bit. Oh, also what you're seeing here is we also allowed it so that the level designer could just put down a spline and then generate platforms along the spline, and then they could also specify the distance between those platforms. So it's a very quick way that they could really lay out a scene and not have to kind of manually like tweak the pixel perfect distance for the platform game. So that was also included in the tool. So it's kind of like a platform game kind of editing tool set that we did. So the thing that I just jumped forward to is showing you the railing. It's a placeholder visualization. It can actually be swapped out for other things. And the cool thing about that, this railing, is that it also supported intersection. So if you start to intersect these railings together, they would politely know how to connect with each other. And you could also kind of create the corresponding gaps. So here you're seeing that it's still kind of got this ugly intersection, but there's a button that we will press to show that, to kind of remove that. Let me see if if I go forward a little bit. So, here we go. Yeah. So yeah, when it gets to a certain point, we can then say, oh, hey, hit a checkbox so that it deals with the intersections how we want it. Just move that in there. So there you go. So it handles all of that stuff. There was a little bit of a problem at very acute angles where it would cause a little bit of kind of texture stretching or awkwardness in the textures. That took us a little bit of time to kind of figure out. That was one of the most challenging things, although you'd think other areas would be, but that was causing us a lot of pain in developing this tool. But pretty happy with how it turned out. And lastly, before I kind of summarize how we use Houdini, I'd like to quickly touch upon effects. We do use Houdini for VFX. Mainly to do things like explosions, we do simulations, although it's not really kind of part of the effects, but we do simulate a lot of the structures and the way that they collapse as well. We do create like interesting kind of trail effects as well that can be used in the game. We also try to make sure that these are editable. So the one that you're seeing at the bottom, the ink one, we try to make sure that it's easily editable and art directable by the relevant directors on the project. It was really challenging because we would output this as an Alembic cache. So the ink effects, the explosions that you're seeing at the top, and that didn't really play nice with some of the real-time engines at that time. So we had to kind of set it up in a way where we could separate out the parts into more optimized pieces that our engineers could then work with, whilst at the same time ensuring that they had a high level of directability for our team. So yeah, to kind of summarize how we use Houdini, I mean, it's not everything of how we use it, and I just wanted to also just mention that this is specific to us. Obviously, it might be a little bit different for your production team studio's needs, but I thought it might be good to just share with you like how we're actually using it in real life. And it might open up some ideas for you. Maybe you might have some suggestions for us where we can actually improve the way we're using Houdini. We're open to input, and I think that's what's great about the Houdini community. They've been great in supporting us, and I'm hoping that what we're doing here today is a little bit of kind of giving back to that and just sharing some of the things that we've learned along the way, the mistakes that we've made. We definitely want to improve, and we definitely think that there's a lot of scope to push some of what we've been doing before, and just trying to find that right balance of like, time, budget, and resources to keep using and pushing Houdini further, and how we're using it. So in terms of like impact and value, it's definitely changed the way that how we hire. Now we include people who are not necessarily overwhelmed by node-based workflows or technical workflows. It's been quite tough to find them, but we'll be spending a lot of time developing and training our own people. So we do want to expand those efforts of growing the kind of technical artists and people who are capable of doing this. It's the only way to make it sustainable for the industry. They don't grow on trees, unfortunately. We now have a much wider range of options for production tools. We don't necessarily have to find more traditional engineers to help make those tools. It kind of opens up a bit more options in terms of resources of who can help us solve production-related problems. We do find it also helps to kind of centralize and better manage and control our assets, the technical setup of our assets. Everything is kind of fed through the same rules and logic in a centralized and structured manner. So that's great. And being able to batch apply that to assets, to batch apply iteration and feedback. Or if there's just been a technical update to the requirements that requires us to make changes, it's great because we can go into a bunch of spreadsheets like a CSV file, make a few changes, or change a few things in the parameters, and then propagate that across the whole world. That's huge. That's a huge impact for us and a huge return on value for us. So before I close out, I just want to talk about some of the future things that we hope to do with Houdini. So far, it's been great for us. And one of the things that I would love to see is maybe integration of the HDA or Houdini engine inside things like Samson's Painter or Samson's Designer. So expanding the options of where you can use the HDA, maybe some more optimization and performance for real-time usage, and maybe even more usage, and I'm not sure, I didn't actually check this, but maybe being able to use it in things like Godot or other engines. We also hope to use more PDG more, and then combine that with more kind of automation on the server side so that we can start to do things like automatically generate variations and then saving those out as presets that can be easily loaded in by the game engine. There's a lot of potential there, and it's not only useful for AAA titles, it can be also very great for smaller scoped games too. I think that developers of all shapes and sizes should really try to think about using Houdini, and even if it's not Houdini, maybe using something that has more of a procedural or parametric nature to it, whether it's Blender node graphs or Unreal Engine blueprints or something similar like this, what Houdini is really empowering people with, these very powerful options that can help to improve efficiency. It does require planning. It does require you to take a bit of an upfront hit in the early phases of production in terms of really figuring out your requirements and then planning for the long term, but it can really help your team. Of course, if you've got a very unique and very stylized game, or if it's maybe a one-off game, maybe it's not something you want to consider, but it's definitely been really impactful for our studio and for the people that we've been working with. And I would like to say this is the end, and I appreciate you sitting here or watching us yammer on about this. A big reminder again, we are hiring, so feel free to email careers@Neon Doctrine. And if you want to follow up or find out more or ask questions, you can find me on the socials here. And I'm now open to some questions if we have any.
Thank you, Solomon. You guys have questions?
Hello. Yeah, super cool talk. So I'm just curious, because you guys will be working with lots of studios, right? And helping out with their pipelines, then how do you sort of help the artists or the designers to adapt to the new workflow?
So one of the first things we do is we assess their comfort level of if are they experienced with Houdini or how much experience they have. Then we try to understand what is their pain points. And then after that, we would kind of propose, like a user story, break it down by features and acceptance criteria, and then kind of plan out a rough kind of high-level schedule for them, and present that to them and discuss it with their team. And then once we're kind of like both on board with the direction of what the solution is, we try to get it to a point that can be tested earlier. We always share movies and we try to share regular process, but we try to get them to test it in production earlier and then either record their screen or give us feedback about if it's working for them or not, and then we iterate from there. We're always kind of reviewing that. The most important thing is to test earlier and then to make sure that they use it earlier, because there's been I've heard horror stories where people have been building out something, an awesome tool. It does everything great, but it's the wrong solution for the wrong problem, and we always try and avoid that.
Right. Thank you.
You're welcome.
Hi, how are you? I get maybe two questions. As you propose solution like that, is there some time that where Houdini price tag came into question, where it's like, then how can you convince a future client perhaps to invest or believe in it? Because I see a lot of people when they see the price tag, they will say, well, but why? Or everything can be cheaper. So that's one question. And I have another one for later.
Okay, cool. It's a really good question. I tell you why, because I've had many internal heated discussions about the price tag, because we need a couple of licenses for us to use, right? And we didn't, it's a long-winded answer, but hopefully I'll get there to the end. But we've been using Houdini for a long time now. I think since we opened the studio, we didn't actually kind of amplify the usage until 1 or 2 years later, until we figured out its positioning in our studio and what we do. And then I had to convince the money people in my team to say, okay, let me give this a try. We're going to need a few more licenses, but we can get it back, right? We can make this work, and we did. We were, I would say, moderately successful, but it became a stepping stone to when we showed other clients or other people how we had used it. Some of them were like, we want exactly that. And luckily, because we'd already been developing that, we already had the groundwork laid down. So what I found was that it was a really long-term return on our initial technical and monetary investment. On the flip side, for clients, they're thinking, oh man, we've heard Houdini's great. We really want to use it. And then we show them and they're like, oh man, we didn't think it was going to be that hard. We do try to offer a middle ground. So the first example that I showed you, which is the Lego block-like pieces, when we built out that whole system and we showed them the logic, it meant that their team could then just focus on building out more parts and more pieces very, very quickly, following the rules that we had already established. And then when it came to them building out another set of environments, because we already had the rule sets in place, all they had to do was follow those rules to build it out. This would then allow them to then think, okay, you know what, we can take our time to get used to using Houdini to kind of build up our own internal people who can then work with us or maybe at some point phase us out and they take it all internally. So it's really about figuring out what is your cost benefit metrics, then communicating that to whoever is the decision makers or the stakeholders on the internal side, on your team, but managing expectations, letting them know that it is a risk. It might not work, just like anything, but it's more of a really, really long-term kind of investment that they need to kind of be in it for the long term to support you through that journey.
Thank you. My second question actually is perhaps about, did you ever experiment with USD and HDA workflow? How the HD asset fit in the USD pipeline versus how the asset can fit in the USD pipeline?
Yeah, we did experiment with that a little bit. We experimented with USD, and there was another format, I forgot, Geometry Cache, Alembic Cache, on those workflows. At that time, when we put them into the engine to use real time, Unreal Engine at that time wasn't so supportive of, no, it was supportive of USD and Alembic Cache, but there was some kind of technical limitations for the projects that we were testing it on. So I think it's great when using it for, film and cinematic work, but for movies and games, depending on the project's technical requirements and specifications, at that time, there was just some things lacking. We do want to use it because we do want to move away from FBX. I forgot the name of the other format. There's another format that we wanna use because FBX is quite an old legacy format, and there's a few other things that I've asked my team to kind of look into to see, okay, what's around now, what's available now. If we were to redo this from scratch, what kind of options do we have? Because there might be some unknown gains that we could win back for development. But yeah, the answer to your question is we did experiment with it. We did like it. It's just there was just a few technical restrictions for our project that meant that we couldn't take it as far as we wanted to.
Thank you so much.
Yeah, so I have another
Oh, it's great.
Yeah, so for your company, you guys are kind of like a procedural team for hire, right? For different studios,
Yes.
right? So is there like a somewhat reusable parts of the pipeline, like a universal asset pipeline kind of thing that you guys develop to eventually customize into a pipeline that the clients can use?
Unfortunately for us, not really. Well, actually, maybe I can answer this in another way. I think the logic and how to use it is reusable, but the specific deliverable is different from client to client because sometimes some of our clients have their own specific game engine. Some of them are on a specific platform, like mobile. So we need to kind of compose things in a different way. And then some of them have a very different artistic vision. So let's take, for example, I showed you those examples of those kind of like urban buildings, right? But if you were then to turn, to try to apply that to something like the Taj Mahal or something that was very culturally stylized, the logic of how those parts combine and work just won't work out. And then you've got the functionality of some of those buildings as well. Urban buildings are great because you've got things like office spaces, schools, hospitals. Their structures can work quite nicely with each other. And then when you've got biomes, right, like in those cities, you can have rules where if X building is close to X object, then put a road there, or put street lamps every X distance from X type of object. You can set these kind of logic in place. But then if you're like on a beach, then you need different like types of logic. So depending on the game itself and the engine, it makes it very, very hard to just reuse like the procedural workflow. But the logic of building out like how the world kind of connects and how the relationship between objects and people and environments are, that logic I think is transferable.
All right, thank you.
Yeah.
Sorry, did you ever experiment or heard about HDA for character animation or like quick NPCs or what joint animation, perhaps?
Yeah, so yeah, we do we do a lot of rigging work and facial work, and we mainly do that. We have our own proprietary tools that we mainly do inside Maya. We did a lot of that work for Resident Evil Village, and then we did look into using Houdini for rigging work to transfer our tools across. Actually, my lead TA, smart guy, he did do a test, and he showed me the results, and the results were promising. We just didn't get a chance or time yet to sit down and just like have a good run to transfer all of our process and our tools. Another thing that we did as well was that we were using Wrap 4D, Wrap 3D, right? And then we actually made a HDA version of the Wrap 3D, which worked just as good. It was, again, like a preliminary test. We do need to kind of like take it all the way to the end. So yeah, to answer your question is, yeah, we did experiment with it. We do see some very promising results. We do want to do more. It's just, we just haven't had the space or time to kind of really invest in it.
Thank you so much. Interesting talk.
Thank you. You're welcome.
Question about maintaining assets. Sounds like you have a lot, like a big library of it. How do you go about just keeping everything in order? I see that mostly like you're doing Unity. Do your clients have like Unreal? You mentioned Godot. We don't have support for that.
Yeah.
But yeah, just general curious question.
Yeah, no, it's a good question. Actually, we don't have a good way to manage all the assets.
Just brute force.
Yeah, we use per force, brute force, and actually, depending on the project, sometimes. So for some of our clients, a lot of our clients they're using per force. So we have a per force server for each project. So it is managed according to that project specification. So in that sense, it's managed, and that project is that client's project. For our own projects and our internal projects, we haven't got a good way to manage it. Now, that's why I was looking at things like the PDG and the server-side stuff, and I did look into things that similar to Quixel Bridge. Quixel Bridge is a very good way to manage kind of like higher poly assets and get the visual stuff, visual kind of thumbnails for it. But there's a few other software that has come onto the market, which is exclusively for managing and maintaining asset libraries. And I am looking into it, and we're trying to do it in a way that allows us to catalog it, but also connect it with the PDG to make adjustments. So my dream is to make sure that the assets are structured in a way that can be used in PDG and on the server side, and then overnight it kind of fudges and makes just adjustments to it, and then it appends it to our library. So that way we are automating the build process of having variations of assets. We did actually start to do that as a test, but it was a manual button that needs to do it, and we didn't connect it with PDG. So the short answer is no, we don't have a good way to manage our internal assets visually in a way that everybody can easily navigate. We use Perforce for now. We have a DB system that uses Perforce. And then on separate kind of confidential client projects, we have separate Perforce depots that we are either connected to on the client side, and we're kind of feeding in from there, and they have their own specifications and requirements for how that is managed.
Okay, thank you. Thank you very much.
Yep. All right, thank you.
Thanks.